use application. Yeah, I will use application so that you can understand the concept clearly. So there will be a case study that we are going to see in the course of this lecture. So it makes our explanation easy to understand. Then we are also going to look at large real data set. Of course, large real data set, you cannot do manually. You have to make use of computers. Then we are also going to look at types of data and information, very important. So later I will share with you some stories on how some students make mistakes by not understanding the different types of data. Then we are going to look at the statistics and how it can be aided by the computer. So computer now make things much easier for us. So let's start with the concept. So what is statistics? So statistics can be explained as a way to get information from data. So in a diagram form, you use statistics to get information from data. So statistics is a tool for creating new understanding from a set of data. So when you have a data, the data itself may not be meaningful. The data becomes meaningful if you apply statistics. So statistics will enable you to analyze the data, to show description of the data so you can get more information about the data. So just to inform you in advance, there will be some tests, very simple tests. It will be true or false. So I encourage you to listen carefully so that when we get to the short quiz, all you need to indicate is whether the answer is true or false. So very easy. But you have to read carefully because it's not very direct. Some of them are direct, some are not direct. So you can also write down some points so if you feel like writing. All right, so let's look at business statistics marks as an example of data. So let's read this scenario. A student enrolled in a business program is attending his first class of the required statistics course. The student is somewhat apprehensive because he believes that the course is difficult. So many students think that statistics is very difficult. To alleviate this anxiety, the student asks the professor about last year's marks. Because this professor is friendly and helpful, like all other statistics professors, he agreed or obliged the student and provide a list of final marks, which are composed of the term work, plus the final exam. So from this example, we can see that one of the students was very smart. He was afraid, so he wants to know how the student performed in the previous class. So the professor was generous enough to provide the marks. Now the question is, what information can the student obtain from the list? So to answer this question is a simple descriptive statistics. So to answer this question that the student is asking, by doing descriptive statistics, you can know more information. You can know the highest marks, you can know the lowest mark, you can know the average mark by just applying descriptive statistics. So you can see that statistics is very meaningful. It enables you to gather information from the data. So this is a typical statistics problem referring to this question. So this is a typical statistics problem. The student has the data, which is the marks, and needs to apply statistical techniques to get the information he requires. So this can be answered by using descriptive statistics. So I'm sure later on in the course of this class, the lecturer will show you how to use the Excel to do simple descriptive statistics. Simple click, 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 you can get the statistics. So what is descriptive statistics? Descriptive statistics deals with the method of organizing, summarizing, and presenting data in a convenient and informative way. The descriptive statistics, it looks so simple, but not only simple, it makes the data more meaningful. It makes the data easy for anybody to see. And it also makes the data to be presented in a convenient and informative way. So let's go deeper a bit. One form of descriptive statistics uses graphical techniques. So these graphical techniques, example is the bar chart, the pie chart, the histogram. So it allows statistics practitioners to present data in ways that make it easy for the reader to extract useful information. So at the end of every semester, we normally show descriptive statistics of student marks. Yes, if we see the marks in the spreadsheet, it looks so messy. But if we want to summarize to know how many students score A, score B, score C, the system will automatically give us the descriptive statistics. So we present to management. So the management are not interested in all the Excel score. They just want to see the summary. So descriptive statistics make it easy for them to see whether the performance of the student is normally distributed, to see how many students score A, how many students score B. Another form of descriptive statistics uses numerical techniques to summarize data. Take note of the underlying word, numerical techniques. So example of this descriptive statistics is your mean, your median. They are the popular numerical techniques to describe the location of the data. It is important to know the mean because the mean tells you the average. So average is very important in statistics, especially by the time you get to the population topic or a probability topic, you will see the importance of mean. It is very, very important in discrete statistics. Another type which captures variability of the data is the range. So the range is the difference between the highest mark and the lowest mark. We also have the variance and the standard deviation. So these are measures of variability. Variability from what? Variability from the mean. So the mean is the center. So we want to see whether there is a big deviation from the center, the mean, or there is a less deviation. Okay, for example, let me give you an example here. Let's say you have a student in this class. I give maybe a short quiz. Maybe the average mark of the student out of 10, let's say is 6. But suddenly we see a student that scored 10 over 10. That student is exceptional. You can see that student is far, far away from the mean. So we can compare the performance of that outlier, only one student that scored 10 over 10 compared to the average student in the class. So we can compare with the mean. So we can see the deviation from the mean. So let's look at this case study. Okay, another form of descriptive, we have covered this. Let's look at this case study. So this is an example of how statistics can help business. So let's look at the case of Pepsi. A large university with a total enrollment of about 50,000 students has offered Pepsi Cola. I'm sure you all know Pepsi. Pepsi Cola, an exclusive agreement that will give Pepsi exclusive rights to sell its products at all university facilities. It sounds very good for the next year, with an option to extend the agreement for future years. But there's a condition. In return, the university will receive 35% of on-campus revenue and an additional lump sum of $200,000 per year. So Pepsi has been given 2 weeks to respond. Now, this is a case study. So Pepsi can do a simple statistics or a simple research, applying statistics to gather some information to know how to respond to this agreement within 2 weeks. So let's see what they can do. So the market for soft drinks is measured in terms of 12-ounce cans. So Pepsi currently sell, so you can see Pepsi now is trying to come up with some statistical values to see whether it is worthwhile to take this agreement. Pepsi currently sell an average of 22,000 cans per week over the 40 weeks of the year. That is 40 weeks in a year. Now, 22,000 Pepsi can per week times 40 weeks equals to 88,000. So they can sell 88,000. So yeah, they are trying to see whether it is worthwhile to take this agreement, but they need some values. They need some data. There is additional information that can sell for an average of $1 each. The cost, including labor, amounts to 30 cents per can. But there's a problem. Pepsi is unsure of its market share, but suspect it is considerable less than 50%. So with simple mathematical knowledge and statistics, Pepsi can manage to solve its problem of not being sure of the exact market share, because this market share information is very important for Pepsi to know whether it is worthwhile to take the agreement. Remember, the competitor of Pepsi is Coca-Cola. So Pepsi need to do some research, applying some statistical knowledge. So let's see the next slide. All right, so a quick analysis, that is, Pepsi is trying to do some analysis now. A quick analysis revealed that if Pepsi current market share were 25%, then with an exclusive agreement, Pepsi will sell 88,000. We've already done the calculation in the previous slide. That is 22,000 is equivalent to 25% of 88,000. So if you convert 25% of 88,000, you get 22,000 cans per week. Or you can make it per year by multiplying 88,000 times 40 to arrive at 3,520 cans per year. So the reason why it is 40 weeks is because there will be semester break, so excluding semester break, so it will not be normal 52 weeks. So that is why they use 40 weeks. So this is the calculation of the net profit. So you can see this is the amount of the sales for 1 year is 3,520,000 multiplied by $1 because 1 can is equals to $1. So the gross revenue is 3,520. Now we need to calculate the net profit. To find the net profit, we have to deduct the cost. In the agreement, the university will receive 35% of the on-campus revenue. So 35% of this revenue is 2,288,000. Now the can sells for an average of $1 each. The cost also include labor of 30 cents. So you multiply the 0.3 cent times the sales for the year to arrive at the cost of labor. Then you minus the fixed cost. The fixed cost is $200. So you do the calculation, you arrive at a profit of 1,032. So based on this information, Pepsi may decide to take up the agreement. So if the profit is a loss, Pepsi will not go into the agreement. So data is important because it helps you to be able to do some analysis. But there's a problem. There's a problem with this making decision on this agreement. The only problem is that we do not know how many soft drinks are sold weekly at the university. That is, Coke is not likely to supply Pepsi with information. Although Pepsi wants to take the agreement, Pepsi must also be careful of Coca-Cola, because Coca-Cola also is a very strong competitor. But it doesn't have enough information about Coca-Cola. And Coca-Cola will not give the information. So which together, it is the combination of the sales of Pepsi and Coca-Cola that make up the largest share of soft drink sales in the university. So Pepsi tried to solve this problem. So Pepsi assigned a recent university graduate to survey the university students. So now we are moving to another type of statistics, inferential statistics. So this case study will lead us to the next aspect of statistics, inferential statistics. Pepsi will assign a recent university graduate to survey the university student to supply the missing information. So accordingly, she organizes a survey that asks 500 students. Now, let me pause here. In the beginning of the case study, there are 50,000 students. But in the course of doing the survey, Pepsi only used 500 students. Why? So later you will see why Pepsi has to choose only 500. It will be too expensive, or it will be too time consuming to survey all the 50,000 students. So in statistics, you are allowed to take sample to keep track of the numbers of soft drinks they purchase in the next 7 days. Okay. The information we would like to acquire in case 1 is an estimate of the net profit from the exclusive agreement. The data are the numbers of cans of soft drinks consumed in 7 days by the 500 students in the sample. So we want to know the mean number of soft drinks consumed by all 50 students on campus. So you see how statistics can be applied to get more information about the case study. So what is the data in this case? The data in this example is the number of cans of soft drinks. To accomplish this goal, we need another branch of statistics called inferential statistics. So we have already talked about descriptive statistics. So now we want to move to the second aspect of statistics, inferential statistics. So what is inferential statistics? Inferential statistics is a body of methods used to draw conclusions or inferences about characteristics of population based on the sample data. Now you can see now the reason why the Pepsi has to choose only 500, because they want to apply inferential statistics that allows you to take only sample of the population, not the entire population. The population in question, in this case, is the soft drink consumption of the university, which is 50,000 students. The problem is the cost of interviewing each student will be prohibitive and extremely time consuming. So instead of interviewing 50 students, you can only interview 500 students. So statistical techniques make such endeavors unnecessary. So instead of looking at 50,000 students, we can sample a much smaller number of students. The sample size in this case is 500. And from this 500, we can infer from the data the number of soft drinks consumed by all 50,000 students. Now, if you want to look at it mathematically, it looks as if it is not accurate. How can you take 500 to make conclusion of 50,000 students? But inferential statistics has been developed such that from the small sample, you can generalize. So that's the advantage. It saves time. So we can estimate our profit for Pepsi by using this simple sample. Now, it is very important because there will be a question that will be coming from this slide. So listen carefully. The difference between population and sample. A population is the group of all items of interest to a statistical practitioner. So in this, our example, in the case study, 50,000 students is the population. So frequently, very large, sometimes infinite. In the case of our Pepsi case, all the 50,000 university students represent the population. Now, the sample, very important to see the distinction. A sample is a set of data drawn from the population. So which means that the sample is a subset of the population. So population is bigger than the sample. The sample is a small part of the population. So in our case study, the sample is 500 students. So you compare 50,000, 500. Now, very important, take note of this slide. There's a question, true or false question. So take note of this slide very well. Parameter and statistics. Sometimes some students, they confuse the difference. A parameter, a descriptive measure of a population. That is, parameter goes with population. Parameter is any measured quantity of a population that describes an aspect of the population, such as a mean or standard deviation of the population. So to remember, anytime you see parameter, it is talking about parameter of the population. On the other hand, statistic is a descriptive measure of a sample. A statistic is any quantity computed from values in a sample, which is considered for a statistical purpose. Statistical purpose include estimating a population parameter. So when we talk about statistics, we are talking about sample. So sample, statistics go together, parameter, population go together. So let's see this diagram to make it easy for us. Now, can you see the population and the sample? So you can see that the population is bigger. The sample is smaller. If you look inward, you will see that you have red, you have blue, you have yellow in the biggest population. Also, in the sample, you have red, you have blue, you have yellow. The difference is that sample is just a small part of the population. So this diagram should enable you to always remember the difference between population and sample. In the previous slide, I told you that population, parameter goes together, sample, statistics go together. So you can see parameter is referring to the population, the standard deviation, for example, of the population. While statistics will be referring to the standard deviation, the mean of the sample. So we continue with our inferential statistics. So descriptive statistics only describe the data set that is being analyzed, but it doesn't allow us to draw any conclusion or make any inferences about the data. Although descriptive statistics is very good, they make the data very easy to understand, but they have limitations. We cannot make some inferences based on descriptive statistics. To solve this problem, we need another branch of statistics called inferential statistics. So inferential statistics is also a set of methods, but it is used to draw conclusions or inferences about characteristics of the population based on data from the sample. So this inferential statistics enables researchers, for example, to take sample of the population, and based on the sample of the population, they can make conclusions without using all the data in the population. Okay, in this case, you've already seen this diagram before. Statistical inference is a process of making an estimate, predictions, or decisions about a population based on a sample. So you can see, so you make inferences based on a sample. So instead of using all this population, you just make use of this small size to make inferences or conclusion about the population. What can we infer about a population parameter based on a sample statistics? Doing this will be time consuming, but focusing on this small part is more easy to do. So once we use this sample, we can generalize. So we save a lot of time and we also save cost. So generally, we use statistics to make inferences about parameter. Remember, parameter is linked to the population. Statistics is linked to the sample. So we use statistics to make inferences about the parameter. Therefore, we can make an estimate, that is prediction or decision about a population based on sample data. Now, this conclusion here is very important. This statement here is very important. So from the sample, you can make decision about a population. Thus, we can apply what we know about a sample to the larger population from which it was drawn. So from what we have discussed so far, so you can see the connections. Descriptive statistics is very important because they categorize data in such a way that you can easily understand using the bar chart, the pie chart, the histogram. But inferential statistics enables you to go further, to do some analysis that cannot be done using only the descriptive statistics. And we have seen the applications of this example in the case of Pepsi. We have seen the number of students that could have been surveyed, but it would be too difficult to do that. As a result, the Pepsi Cola has to use inferential statistics. You can see how they are applying it, applying the inferential statistics to be able to reduce their time and their costs. So they pick only 500 sample out of the 50,000. Later on, your course instructor will teach you population sampling, random sampling and non-random sampling. So random sampling is preferred. It's preferred. Why? Because if you want to make decisions, especially important decisions, it is better to use to focus on the sampling method. Yeah. But if you are not making decision, then you can use other categories. Okay, what are the rationale? Why do we have to use sample instead of the larger population? Larger population make investigating each member impractical and expensive. Example, in our case study, 50,000 is too large to interview. So 500 is more manageable. Another rationale, it is easier and cheaper to take a sample and make estimates about the population from the sample. However, this one is very important. However, such conclusions and estimates are not always going to be accurate because we are only picking 500 out of 50,000. The conclusion will not always be accurate. For this reason, we build into the statistical inference measures of reliability. Now, this measure of reliability, example of them is confidence level and significance level. So now, in the next slide, we are going to see another important concept called confidence level and significance level. So I will ask you a question later regarding this confidence level and significance level. So you must take note of the differences. So let's start with the confidence level. But remember the progression. It was as a result of the limitation of inferential statistics that give rise to the need to have confidence level and significance level. So these two enable us to assess how we can rely on the inferential statistics. So let's see the difference. The confidence level is the proportion of times that an estimating procedure will be correct. Now, take note of the definition. The confidence level is the proportion of time that an estimating procedure will be correct. To make it easier for you, a confidence level of 95% means that estimate based on this form of statistical inference will be correct 95% of the time. So 95% is very good enough. So we can be confident that our statistical inference is reliable. On the other hand, when the purpose of the statistical inference is to draw a conclusion about a population, the significance level measures how frequently the conclusion will be wrong. Now, take note of the difference. Confidence level tells us whether we are correct or not in percentage terms. The significance level talks about the probability of being wrong in the long run. So take note of this difference. I will ask you a question later relating to these two. For example, a 5% significance level means that in the long run, this type of conclusion will be wrong, only 5%. So if you are making inferences from a data and you only have 5% chance of being wrong, it's still okay, because 5% is still considered minimal. If it is 1%, it's even better. So it means you have 99% confidence relying on your conclusion. But at least 5% is the benchmark. 1%, okay. So for us to understand the relationship between the confidence and the significant level, if we use a Greek letter alpha to represent significance, then our confidence level will be 1 over alpha. Now, if you look at this, if you do some addition, 95% plus 5% equals to 100%. So which means that if we know our significance level, we can easily find our confidence level. So significance level plus confidence level always equals to 1 or 100%. That is the relationship between the two. If you know confidence level, you can calculate significance level. If you know significance level, you can calculate confidence level. So let's consider this statement. Let's say you find this statement maybe in a TV or somewhere in the newspaper. Consider a statement from polling data you may hear about in the news. This poll is considered accurate within 3.4 percentage point, that is 19 times out of 20. So 19 divided by 20 times 100 will give you 0.95. So while our significance level will be 5%. So with this kind of statement, we can easily calculate what will be our confidence level, because 19 is close to 20. So we can calculate the percentage. Okay, now, because we have talked about data, especially in our case study, so we need to also know the different types of data. Now, I promised to share with you some of the experiences or some of the things that I've experienced in the course of teaching students, because I was once a teacher also at the secondary level before joining the university. I also do tuition in some orphanage homes also. So I see some confusions in terms of not understanding the difference between variables and data. So now we are going to look at the definition of a variable. A variable is some characteristics of a population or a sample. So variables can be related to population. It can also be related to sample. For example, student grade. So student grade is an example of a variable. So it is typically denoted with a capital letter X, Y, Z. So the variables can also be profit of a company. It can be sales of a company. Now, the values of the variable are the range of possible values for the variable. So the variables will be assigned values. Now, let's look at the data. Data are the observed values of a variable. So you can see that variables, values put together make up data. Data are the observed values of the variable. So to understand data, you need to understand variable as well as values. Combined together makes up the data. For example, student marks. So student marks is the variable. The marks can be 67, 74, 71, 83. So take note of these distinctions, because it will help you later on when you get to regression analysis. So you understand what is data, what is variables, what is values. Now let us see different type of data that you can come across in statistics course or in business statistics course. So one of these data is called hierarchical data. Data, at least for the purpose of statistics, fall into three main groups: interval data, ordinal data, nominal data. Now, if you look at this data, they are arranged according to the order of importance. Interval data, you can do many things with interval data. It's the most preferred data, because you can do any type of analysis on this data. The next important is ordinal data. Then the least important, also important, but in terms of ranking, least important is the nominal data. So later on, you will see why the interval data is considered the most preferred. The data types can be placed in order of permissible calculations. At the top of the list, we place the interval data type because virtually all computations are allowed. You can do any type of calculation using interval data. The nominal data type is at the bottom. Why? Because no calculations other than determining frequencies are permitted. So you cannot do so much with nominal data, but you can do a lot with interval data. So let's start with the interval data. Interval data refers to real numbers. So real numbers, for example, the height of the student in this class. So the height of the student in this class is an example of an interval data because it has a numerical value. the weight of each student in this class is an interval data. And the prices of a business product is also an interval data. So this type of data, you can do so many things with it. This data is also called quantitative or numerical data. So you have learned another new thing. Sometimes they call it interval data. Sometimes they call it quantitative data. Sometimes they call it numerical data. This type of data, you can perform arithmetic operations on interval data. Thus, it is meaningful to talk about 2 times height. You can see 2 times height, you can easily find the value. Price plus $1, you can easily find the value. So you can do multiplication, you can do addition, you can do minus, you can do division, you can do square root, you can do cube root, all kind of mathematical calculations can be done with interval data. Another type of data is called the ordinal data. Now, these ordinal data appear to be categorical in nature, but their values have an order or a ranking to them. For example, college course rating system. I'm sure you are all familiar with this type of grade. Poor equals to 1, fair equals to 2, good equals to 3, very good equals to 4, excellent equals to 5. Although these ordinal data, they look meaningful, it is very difficult to multiply 2 times fair. So you cannot multiply 2 times fair. You cannot multiply 2 times good. It is useless. You cannot multiply 2 times very good. It is useless. The thing you can only say is that excellent is greater than poor. Okay, that one is okay. Agreed. Fair is less than very good. Okay, agreed. But you cannot say 2 times fair equals to 2 fair. You know, it's not possible. So you can see the ordinal data has limitation, but it can still be used. It can still be used, but it's good to know the limitation. So I have seen some students, due to poor understanding of how to use ordinal, they treat ordinal like in numerical variables. But if they had known that ordinal has a limitation, they wouldn't have treated, because for the student, 4 equals to 1. So 1 times 2 equals to 2. No, you cannot do that in ordinal data. So 1, 2, 3 is just to show which one is higher, but you cannot multiply. But this particular student in question, during my high school days when I was teaching, they used to multiply. 1 times 2, they tell me it is poor fair. You know? So there's nothing like that. That is, order is maintained no matter what numerical value are assigned to each category. Okay, so maybe I think we can take a short break. Is it permissible to take a short break? Dr. Ibrahim? Dr. Ibrahim, so can we take a short break?
Yes, Doctor. You can do that. Yeah.
All right. I took a course with Harvard University, so they told us that it's good to give break.
Okay, Doctor.
All right, thank you. So we'll come back after 5 minutes. So you can go to washroom, you can take water, then we'll continue 2:56. Or that will be 1:56 in Indonesian time.
Great.
So we continue 1:56. All right. All right, so let's continue. So we have already covered this slide. Just to summarize, So what this slide is telling us is that ordinal data does not allow you to do multiplications. You cannot do subtractions. You cannot do division using ordinal data. What you can do is to compare poor and fair. So we know that fair is better, poor is the least, is the lowest. So we can say that excellent is better than very good. Very good is better than good. Good is better than fair. Fair is better than poor. But we cannot say 1 times 2 equals to very good. So it cannot be done. Another type of data is called nominal data. Now, this nominal data, it has a lot of disadvantages. The values of nominal data are categories. So the value of nominal data, they are categories. For example, responses to questions about marital status coded as single equals to 1, married equals to 2, divorce equals to 3, widow equals to 4. You can see this type of data, you cannot do anything. You cannot do multiplication. You cannot even say that married better than single, widow better than married. It doesn't make much sense. So you can see that there is little you can do on nominal data. So these data are categorical in nature. So arithmetic operations don't make any sense. There is nothing you can do on this. It doesn't make sense. Can we say that widow divided by 2 equals to married? It doesn't. You cannot do that. You cannot divide widow divided by 2 equals to married. There are many things you cannot do. So nominal data are also called qualitative or categorical data. So let me say this. By the time you get to regression analysis, because it's part of statistics, categorical data can enable you to measure important variables, which it is difficult to find numerical values. So in multiple regression, or in particular, you can actually capture some important values or variables that are categorical in nature. For example, you want to compare the performance of Muslim buyers and other religious buyers. So you can use categorical data because you will not get values about religion, but you can use idea of nominal data to still measure those type of important variables. Or you want to capture the difference between the buying behavior of male and female. You can still use nominal data. And you can incorporate it also in the regression. It's possible. And when you get to the regression stage, let me say this also, many students, they interpret the numerical data as if it is quantitative data. They are not the same. When you want to interpret the nominal data, you compare between the male and female. You will not say that you will not interpret it to mean that increase in the male will increase your dependent variable. So when you get to the regression, you will see the limitation of nominal data in the context of interpreting the meaning in a regression is slightly different. So to summarize all what we have said about the types of data and the information. So as mentioned in the previous slides, all calculations are permitted on interval data. So that's the reason why it is considered to be the most preferred. Only calculations involving a ranking process are allowed for the ordinal data. So for the ordinal data, we have seen the example, we can say excellent, more than very good. No calculations are allowed for nominal data, save counting the numbers of observation in each category. So this lends itself to the following hierarchical data. So that's the reason why the first slide under the types of data and information, we started with the hierarchical data, meaning that in order of importance: interval, ordinal, then nominal. Very importantly, this slide also gives us important summary of what we can do with each of these type of data. In interval data, values are real numbers. For example, height, weight. All calculations are valid. You can plus, you can divide, you can minus, you can square. Data may be treated as ordinal or nominal. You can see everything is possible under interval. But ordinal, values must represent the rank order of the data. Calculations based on ordering process are only valid, only based on the ordering. You cannot do anything more than the ordering. Data may be treated as nominal, but not as interval. So you can see you cannot treat ordinal as an interval data. Now the third one, nominal data. Values are the arbitrary numbers that represent categories only. Only calculation based on frequencies of occurrence are valid, not division and multiplication. Data may not be treated as ordinal or interval. So you can see from these characteristics that the interval, you can do many calculations with the interval data. Now, very importantly, statistical application in business, because in business, you are dealing with large volume of numbers. So to calculate manually is practically tedious and difficult to achieve. So there are different types of statistical applications that can be used to improve these calculations and to make descriptive statistics easier to present. So statistical analysis play an important role in virtually all aspects of business and economics. For example, in virtually all applications of statistics, the statistics practitioner must deal with large amounts of data. For example, in the case of Pepsi Cola, it involves 500 observations out of the 50,000. But even this 500 observation, calculating addition manually can be very tedious. Doing multiplication manually can be very difficult. So to estimate annual net profit, the statistics practitioner will have to perform computations on the data. Although the calculations do not require any great mathematical skills, the sheer amount of arithmetic make this aspect of the statistics method time-consuming and tedious. It is still time-consuming. So computer can make things much easier for you. So that is why in this statistics course, I believe you also be exposed to Excel. At least every business student is supposed to know how to use Excel. So if you can use other application, very good, but at least minimum Excel, you should know how to use it. So fortunately, there are numerous commercial prepared computer programs. They are available to perform arithmetics. For example, the Microsoft Excel is mostly used. Why? In the belief that virtually all university students use it now and will continue to use it in the future. So Microsoft Excel is very simple. With little effort and little practice, you can easily do a lot of calculations with Excel. So Excel can perform statistical procedure in several ways. All you need to do is simple practice and practice and practice. Okay, now, so it's now the feedback. So I have just 2 slides just to test how you have learned 1 or 2 things that I consider important. So all you need to indicate is true or false. So if you want to answer, say the answer. So you just indicate, just tell us your name, then you tell us whether the answer is true or false. So the first question, the significance level measures the proportion of time and inferences about a population will be correct in the long run. So think before you answer. So do you think the answer is true or false? Remember, I was telling you to take note of the difference between significant level and confidence level. So if you have taken note of that, then you should be able to answer this question. So who is going to help us with the answer? Is it true or false? Even if you are wrong, it's okay. Just make effort. Take effort to read, then tell us whether it is true or false. So this one, I'm referring to this. So is it true or false? Or if you are bold enough, just tell us whether it is true or false. So if you are shy to mention your name, so just be bold. Just say true or false. So who is going to help the class? Somebody must bail out the class. The answer is in the... So what's the answer?
The answer is false.
Thank you very much. So thank you very much. So take note. So usually in my class, a student answer, I blancher them some marks, to encourage others. So I wish I can give you 1 mark, for answering the question. All right, thank you very much. All right, let's see the second question. A descriptive measure that is computed from a sample is called a statistic, true or false? The answer also is in the slide. A descriptive measure that is computed from a sample is called a statistics, true or false? I remember I spent some time trying to highlight this part, and I told you I will ask you a question on it. So true or false? Take your time to read carefully.
Excuse me, Mr.
All right, you want to help us?
The answer is true.
Thank you very much. So it shows that you are listening. Yeah, so that is how I get feedback to see whether you are taking note. I know you cannot remember everything, but at least if you can remember some things, then you make the instructor happy. So the instructor is happy that you listen. All right, so the third question. So this one, don't rush to answer it. The confidence level is the proportion of times that an estimating procedure will be wrong in the long run. Don't rush to answer it. It is very tricky in a way. So read carefully. Take note of this one, and this one. So you refer back to what I said about confidence level with the example, then you will know the answer. True or false? So who is going to help us?
Excuse me, sir.
All right, so help us.
The answer is false.
Thank you very much. So you see, this type of question, it is very easy for students to say true. So this type of question, you want to test whether you pay attention to details, especially some keywords. Sometimes the way they will ask you the question, it will look as if it's true. But when you take careful note of the keyword, then you will know that even though it looks like true, it is not true, because something make the answer to be wrong. So I usually use this method to test my student. So they tell me, doctor, very easy, true, false, true, false. I say, it's not easy. You have to read first, because true, false, you can choose the wrong one also. So you have to be very, very sure it is true or it is false. So thank you very much. Okay, so this is the last question. This is the last slide for the question. Statistical inference is the process of making an estimate, prediction, or decision about a population based on sample data, true or false. The answer also I mentioned in the slide is also in the slide. True or false. So who is going to help us? I think this one is straightforward. This one is not, it's not very tricky. It's straightforward. If you listen attentively to the explanation in the lectures, you should be able to know whether it is true or false. So who is going to help us?
Excuse me, Mister.
All right, thank you.
The answer is true.
Thank you. The answer is true. So it shows that you have gained something from today's class. So let's look at the next question. You take a random sample to estimate a population mean, and your result have a confidence level of 80%. So that means the process you use will give you correct result 80% of the time, true or false. So this one is related to confidence interval. I remember I also spent time to explain this part. So true or false, very simple. True or false.
The answer is true.
All right, thank you very much. The answer is true. So it shows that you are a smart student. So the last question, I also told you I will ask you this question while I was explaining in one of the slides. A descriptive measure of a population is called a parameter. A descriptive measure of a population is called a parameter, true or false? If you remember, I was explaining to you population, parameter, statistics, sample. I was repeating myself because I know I will ask you the question. So now is the question, true or false? So who is confident? Even if you are wrong, somebody else will get it right because you only have two options, true or false. So if one student is wrong, the next student can easily get the answer because you have just true or false. So it's okay. So what's the answer?
The answer is true, maybe.
True. So you try. So 50-50 chance, but you managed to get it right. But don't rely on luck. Always make sure you know the answer because sometimes luck may not be luck. But now you are lucky, you are right. So the answer is true. So I remember I showed you, okay, let me show you where the answer is in one of the slides. Because there was a diagram and I was trying to emphasize, can you see population, parameter, sample, statistics. So I still remember this slide again. You see, population, parameter, sample, statistics. So luckily you are able to get it right. So good guess. Good guess. All right, so I think we have come to the end of today's lecture. So thank you for your time. I also thank Dr. Ibrahim for the opportunity to share some information about business statistics. So I really appreciate. And I also thank the student. If there is no student, I cannot deliver the lecture. So you can imagine if I come to the Zoom and all the students not there, then I'll be talking to the Zoom only. So thank you all for coming. And most importantly, thank you for participating. This one is very important. Because you participated, I feel more happy because the student can get all the answer correctly. So I feel happy. So thank you for all those that answer. And for those that don't answer, I know that you know the answer, but maybe you don't want to answer. But it's okay. As long as some sample out of the population of the student answer the question, I'm happy. So I can give conclusion that probably I am 95% confident that all the remaining students, they also know the answer. So you can see we already apply statistics to arrive at our conclusion. All right, any question? Okay, so if there's no question, so I hand over the time to Dr. Ibrahim.
Maybe thank you very much. Yeah, thank you very much, Professor Bolaji, for sharing your knowledge, sharing your experience, and also gave us a very good thought about the business and statistics. Thank you very much again, and I hope we can meet each other in the near future.
Yeah,
thank
sure.
you.
Most welcome.
Thank you, students. Yeah. See you. Bye-bye.
Bye.
Thank you, sir.
You're welcome.
Thank you, Mr.
Welcome.